In the last video, we built the brain of our health system. It's modular, it's clean, but let's be honest, it still looks a bit boring. Right now, when our enemy takes damage, nothing happens. No flash, no sound, no impact. There's a total lack of juice. But because we used a decoupled, component-based architecture, we don't need to touch our core logic to fix this. Today, we're finishing the build. We're going to plug in the Lego bricks that handle the fun stuff, like hit flashes, floating text, sound effects, and even a health bar. By the end of this video, you won't just have a health bar that works. You'll have a combat system that feels amazing to play. And as a bonus, I'll show you how you can drop these feedback components into any future project without rewriting a single line of code. I'm D, let's get started. The hit feedback component is the visualizer. It listens to the health component. When the health decreases, it briefly changes the enemy's sprite color to flashing red and plays a hit animation. At a high level, this script handles the visual feedback when the enemy takes damage. Instead of mixing visuals into the health logic, this component listens to the health component and reacts by flashing the sprite and optionally playing animations. You can customize the effect by using flash color and flash duration, and optionally define hit animation and idle animation for the animated sprites. Internally, it stores the original modulate color so it can revert after flashing, and keeps track of previous health to detect when damage actually occurs. The onHealth change function acts as a filter. It checks whether the health actually decreased. If the current health is lower than the previous value, it means damage was taken, so it triggers the flash function. It then updates previous health to keep tracking future changes. The flash function handles the visual effect itself. It first ensures the sprite is still valid, then changes its color to the flash color and plays the hit animation if available. It uses a wait with a timer to pause for the flash duration without needing a separate timer node. After the delay, it safely reverts the sprite back to its original color. If a hit animation is playing, it waits for that animation to finish before continuing. Finally, if the enemy is still alive, it transitions the sprite back to the idle animation. Otherwise, it simply exits, allowing other systems like death handling to take over. The sound component is essentially the audio player. It listens to the health component for damaged and died signals. It spawns independent audio players into the main scene to play the grunt or death sounds. I chose to spawn the sounds in the main scene so the audio doesn't abruptly cut off when the enemy node is deleted. It's important to note that for simplicity, I used Audio Stream Player, which handles global audio, instead of an Audio Stream Player 2D, which uses positional audio. This means there's no need to calculate the enemy's position. The system just creates the audio players, assigns the stream, adds it to the scene at 00, and plays it. As a result, the sound plays at a consistent volume no matter where the player is in the level. And that consistency is the main trade-off of using global audio instead of positional audio. The Hurtbox component is the receiver. At a high level, this Hurtbox component is responsible for receiving damage and passing it to the health component. It doesn't decide how damage works. It simply listens for collisions and extracts the damage value from whatever hit it. The key moment happens in on area entered. When another area 2D overlaps with this Hurtbox, the script first checks if that area belongs to a specific group. By default, player attack. This is how it knows what counts as an attack, so only areas in that group are treated as damage sources. Once it confirms the collision is from an attack, it figures out how much damage to apply. Now, this is where the damage actually comes from. The script looks at the incoming area and checks if it has a damage property. If it does, it pulls that value using area.getDamage. If it doesn't, it throws a clear error because something is incorrectly set up, like an attack without a damage value. Finally, it passes that extracted damage amount into the health component via take damage. So now it's only fair that we look at the Hitbox component on the player that I mentioned earlier in the video. Think of the Hitbox component as the offensive side of a passive-active relationship. The Hitbox component is completely passive. It doesn't actively look for things to hurt. It just exists in the physical world as an area 2D, holding a damage value. In this case, 10 damage. During its ready function, it automatically tags itself into a group called player attack. From there, its job is done. It simply waits in the world as a weapon or hazard until an active Hurtbox component touches it, reads its tag, and takes the damage. This damage text component is part of the UI feedback. It listens for the damage signal. Whenever damage is taken, it spawns in a little floating damage number into the world scene, applying a slight random offset so multiple numbers don't perfectly overlap each other. The dead particles component spawns a visual effect like an explosion at the moment the enemy dies. In the inspector, you assign two things: the health component that it listens to and the dead particles scene you want to spawn. When the game starts, it connects to the died signal from the health component. That will check when the enemy health reaches 0 and the died signal is emitted. Once that signal fires, the component instantiates the particle effect and adds it to the main scene so it doesn't get deleted with the enemy, and positions it at the enemy's global position for a seamless effect. Now that we understand the core concepts and principles behind this modular system, let's look at a tool that can help speed up our workflow. For the dead particles, we could build everything from scratch. But to save time, I'll have the Ziva AI assistant generate a great starting point. Then I'll walk you through how I manually tweak those parameters to fit our decoupled architecture. That said, it's important to stress, you should absolutely build something like this yourself at least once. Tools like this are mostly useful when you already understand what's going on under the hood and just want to move a little faster. If this part doesn't interest you, or you already know how to create particle effects, you can use the timestamp to skip ahead. But stick around because the best is yet to come. I'll show you how to import this system into another project. First, create a new 2D scene and rename it to Hit Particles. Then add a script with the same name and save it in your particles folder to keep things organized. Next, add a GPU particles 2D node as a child. Then assign your desired texture in the inspector. You'll notice a yellow warning icon. This simply means the particle needs a material to function. To fix that, go to the Process Materials property and create a new particle process material. Once that's set, save the hit particles scene. And now for the fun part. We can write a prompt to let our AI assistant generate a solid starting point for the particle system. Can you create a hit particles effect using the Hitparticles.tscn? Use the texture that I have added to the texture field in the inspector and have random particles explode of different sizes in a circular pattern. Let the particles be green and yellow and have it removed from the game when it's completed. Use the Hitparticles.gd for any necessary code. And just like that, your AI assistant has generated the particle effect. So now let's take a closer look. After reading Ziva's explanation, one thing stands out right away. The particle scale ranges from 0.5 to 1.5, which is much too large for my game, so we'll need to adjust that. The colors look good, it correctly used the texture I provided, and it added the code to automatically remove the particle system once finished. Now, to preview it, we can go to the inspector and toggle the emitting checkbox. And As expected, the particles are too big. We open the process material to see all the parameters Ziva configured. Then we find the scale setting and bring it down to better match our game's proportions. Then toggle emitting again to test the result. From there you can fine-tune anything else. I slightly increase the particle count and reduce the lifetime to around 0.5 seconds. Once everything looks right, we save the scene, assign the particle to the death particle component, and run the game. Now, when the enemy dies, the particle effect plays exactly as intended. And lastly, we use a progress bar to display the health. The health bar component uses a simple UI element that can visually represent the health by linking directly to the health component. When the game starts, it initializes its max and current values to match the health state and hides the default percentage text for a cleaner look. It then listens to the health change signal, so whenever the enemy takes damage or heals, the bar updates automatically. No extra scripts are needed. It also includes a quick validation check to warn you if no health component is assigned. Now, as promised, let's use this in another project. In the previous part of this series, I showed how to build a data-driven system where we created multiple enemy types using JSON and custom resources. This time, I want to show how we can reuse the same system to add a health system to our player from that project. First, we turn our component node into a scene. Just right-click the component node and select Save Branch as Scene. Then save it in the feedback folder. Once that's done, we can simply right-click again and make the instance in our main scene local again to expose its children and save the project. Next, we move the system into our other project. Right-click and open the feedback component system folder in your file manager. Then grab the entire feedback systems folder, including all its dependencies, and drag it into the new project. In this case, the data-driven project. Because everything is neatly organized in one folder, it transfers cleanly and, as you will see, works right away. Now that it's in the new project, let's show how flexible this setup really is by adding it to the player, even though the player can't attack in this version. The first step is to right-click the player scene and choose Make Local. This exposes all its children. Then drag and drop the component scene into the player and once again make it local so you can access and edit its children. From there, go through the inspector and assign any required references. Most will already be set since we saved this as a complete scene. The main things left are assigning the player body to the actor field in the health component and the player's animated sprite to the sprite to flash field in the hit feedback component. Once that's done, you'll notice the health bar appears on the player and everything is already working visually. To allow the player to take damage, we're using a sniper enemy that fires projectiles. So we'll add the Hitbox component to the enemy's shot. Just drag and drop the Hitbox component scene into the projectile. We can reuse the existing collision shape 2D by making it a child of the Hitbox component. Then remove the old area 2D node since it's no longer needed. Now, when we run the game and move into the enemy's line of fire, the player takes damage and in this case dies immediately. Now, that's a bit too harsh, so we can easily tweak the damage value and the player health. And just like that, you've got a fully modular, reusable health and feedback system that can plug into almost any project. As I mentioned earlier, you'll find a link to the project files on the game's itch.io page, along with the links to the rest of the series and the Ziva AI assistant in the description. If this video made you stop and think about how you're learning Godot and not just what you're building, then you're exactly who this channel is for. I make videos for developers who want to understand their code and have the discussions that tackle the difficult topics. So, if that sounds like you, hit subscribe. You'll feel right at home here. And before you go, answer this in the comments. Do you organize your systems into reusable components like this, or project-specific scripts? And how would you expand this system? What feature would you add next? I'd really like to know. Until next time, happy coding, keep experimenting, and I'll see you in the comments. This has been Diragu Games.